Hello guys, my name is Jeferson Costa, I'm a chemical process engineer, and today we'll talk about how to start reading a P&ID. Enough from my face, let's go to the screen. Before we start, I would like to invite you to visit my other social media like YouTube, Telegram, LinkedIn, and my fan page in Facebook. I have a special invitation to you join my Telegram channel, because there you have much more about chemical process engineering and plant design. And just to let you know, I have a surprise for my in-process members, and in the end of this video they will know what I have prepared for them and for you that is watching this class. To start talking about reading P&ID, I would like to share with you a screen of my blog, and some time ago I did a post about discussing if P&ID is piping and instrumentation diagram or if it means process and instrumentation diagram. There were a discussion about that in my LinkedIn, and what really matters is that P&ID is a multidisciplinary document in the plant design, so not only the chemical process engineer uses that, but also the mechanical guy, instrumentation guy, automation team, and piping also, and eventually the civil engineering will have some information in the P&ID too. And just to give you a definition of P&ID, I will use the ISO definition that says to us that the P&ID is based on the process flow diagram. It depicts the technical realization of a process by means of graphical symbols representing equipment and piping together with graphical symbols for process measurement and control functions. And that is the main goal of the P&ID, that is to have in only one document many information as possible in order that the team in plant design can build and erect a plant. There are other standards that discuss about P&ID, and some of that is the process industry practice. There are also the South Australian Water Corporation and a very famous international standards for automation, and I recommend you to take a look on them to have a better view what is the importance of this document for process engineering, plant design, and get familiar with piping and instrumentation reading. As many of you, I didn't learn how to read P&ID in the chemical engineering course. I did a bachelor in industrial engineering with emphasis in chemical, but at that time I was not aware of how important would be the P&ID or pipe instrumentation diagram for working with plant design. And it can be very intimidating at the first sight, and with this video and with this class you will have a better sight about pipe instrumentation diagram, and you will not be afraid of getting a P&ID for reading. And in this class I will use two examples with you, and you can see that they have different background, because this one, the first one, is a nitrogen compressor, and the other one is based on a direct cooling tower. Just to let you know, the software I'm using right now is the AutoCAD Plane 3D 2020. It is a student version, so it means it is for free. I don't need to pay anything to use that, and it is not cracked also, no crack needed. And if you like to know how to download it to you, you can click in the alert and see the video how is the step-by-step to have the AutoCAD Plane 3D for free. And to continue this class, I'll return to the nitrogen compressor. So my goal here is to share with you at least 3 tips of how starting reading a P&ID. And the first thing that you should do when consulting or verifying any documentation, engineering documentation, is get a look at the stamp to verify if you are using the latest documentation available for your project. So I will not get further in the stamp, but it is very important not only verify, and if you are developing a new documentation, that you feel that correctly also. The first tip is that if you are facing a new process and you don't know anything about that, is that you should follow the flags. And the flags show you what is going inside and what is going out from your process. And usually we start drawing a P&ID from the left to the right, and when it is possible, we start in the middle of the paper to make it easier for the understanding. So in this example here, you can see that we have a stream going inside in the drawing. So we have here the flag. This is the flag, what I'm talking about with you. And we have something that comes from somewhere. So it's coming from another sheet, and it is nitrogen vaporized. So this stream comes from the nitrogen vaporized, and it calls another sheet named T01. So every time that you see your flag pointing out from the right, it means that you have a stream getting inside to your drawing. In the other hand, you have here another flag pointing out to outside of the drawing, and you have here 2 battery limits. It means that the discharge of the compressor is going to another sheet, in this case X01, and the X01 is the P&ID sheet that is related to the battery limit. And to clarify what we have here, it is a nitrogen compressor. So we have the identification of the sheet in the stamp here. We have the tag of the equipment also, and in this case we have a reciprocating compressor with 3 stages of compression, and we have also aftercooler for each stage. It takes the nitrogen from the vaporizer, and we build some pressure in the first stage, and because when we compress a stream, it gets hotter, and it is especially true when we are talking about gases. We need to cool down this stream to not damage the second stage of compression. So in the second stage, we build pressure again, and because of that, we increase the temperature of the stream again, and we need to cool down. And the third stage is the same, so we compress, the pressure increases, the temperature increases also, and we need to cool down the stream to send that to the battery limit. If you had a process downstream that needed to be heated, eventually we would not have the aftercooler, because we could save some energy in this process. And to do the cool down of the gas, we need some source of cooling. In this case, we have water. So as you can see, we have the stream of water from the left, from the right, like we have in the gas stream. And we have here cooling water from sheet U01, and the stream gets to oil cooler, and after that go to the compressor casing, and it returns for a header where it is collected all the return water, and we have a header with all the supply water. So we cool down the casing of the compressor only in the first stage, and after that we supply water for the aftercooler. So we have 3 aftercooler here in this equipment. What will help you also to understanding the process is the arrows that you see in each stream. It tells you the direction of the stream. So here I have a stream from the left to the right. Here I have it from the top to the bottom, and you can see that in the cooling water system. And as we have only a straight line in the nitrogen stream, we don't have an arrow in the main line. What would help you also to understand what is the main stream in a drawing is that some companies uses a thicker line to represent the main process. So you can see that the nitrogen line is thicker than the cooling water line. So the cooling water line is a secondary step in your process, and the thicker line is the main reason for the process. So my first tip to you is to take a look in the flags and the arrow direction, because they will tell you what is the starting point and the ending point of your process in the P&ID that you are reading. Let's go to the other process and you see the same. We have the flags, and this flag is visually different than the other P&ID, but has the same function, that is to represent that the stream is getting side to your process. So we have a flag pointing out to the right, so it means that we have something getting inside the drawing, and here in the bottom we have a flag pointing out to the left, so it means that it is going out from the drawing. You can see that in this case there are no thicker line to show you what is the main process line in this process, but once you get familiar with the process, you will understand what is the main line in your P&ID. Just to explain better what's happening here, we have a gas line that goes to a direct contactor tower, or it can be known also as a direct contact aftercooler. The gas enters in around the middle of the tower, and it goes up, pass through a stream of water, and at the top we have cooled gas that goes for C301 in the sheet C01. You can see that it is the representation, a flag representation going out from your drawing. And in the other hand, we have a recirculation pump here, one standby from another. It could be running in parallel, but in this case one is in standby, and we have here a heat exchanger where we have a cooling media going from CH801 from sheet N01, and we have a heat exchanger here, and the stream return for the CH801. And you can see also the arrows showing you the correct direction of the process. So in this case we have the stream coming from the left, from the right. We have an arrow here entering the tower, and we have in the top another arrow showing that the gas goes out from the top of the tower and go to the outside of the P&ID sheet. Now we go to a second step, that is identify the pipe numbering or line numbering, because once you understand the line numbering, you get valuable information about your hydraulic system. And in this case, in the nitrogen compressor, you can see that from the nitrogen vaporizer, we have a pipe identified as 4 inches NG0100 CS 150B. Most of the piping numbering is very similar. Usually we have at first the pipe size, the nominal size of the pipe, and it can be in inches or in millimeters depending on the kind of material or the standard that you are using in your project. And we have here 2 letters, and in this case it means that we have nitrogen gas, and we have a sequential number, and it could be the identification of the area plus the sequential number, but in this case we have only the sequential number, that is 0100. We have also the information of the piping material, so in this case CS means carbon steel, and the 150 is related with the pressure class of this piping system, and with that I know what is the maximum allowable working pressure based on temperature of operation, or also based on the project temperature. And B is a kind of material related to carbon steel. Once you get familiar with P&IDs, you start understanding the line numbering for any kind of P&ID, but the correct way to know what represents each information in line numbering is consulting the instrumentation legend and symbols of your project. And just to compare with the other project, let's see how it is the line numbering. In this case, you can see that we have a similar structure from the previous P&ID, and in this case we have 800. Here we, instead of the pipe size in inches, we have the pipe size in millimeters, and you can see just upstream the line numbering that we have here a valve. This is a butterfly valve of 20 inches, and as we have no reduction from the valve and the pipe, 800 is equivalent to 20 inches. And in this case, NG is not nitrogen gas. It's not about that. Here we have a methane plant, so we need to do a purification of a stream with methane, and in this case NG means natural gas. And the material is stainless steel, SS, and the line numbering is 302. So although the line number for each other project is very similar, to confirm the information you always need to verify the legend and symbols table. And why it is important to load the line numbering? The first thing is that you can identify the fluid that is going through your process. So in this case we have natural gas. If I'm building my process simulation based on an existing plant, sometimes we don't have a process flow diagram and we need to build one based on the field information. And here I know that I need to add to my simulation the natural gas, or I don't have the composition, but I know with this that I have a flammable gas, and I know also the material of the piping, so that is very important when I doing the calculation of pressure drop in the hydraulics. And I have what is some of the most important information for us chemical engineers is the pipe size, because based on that I can calculate the fluid flow and the pressure drop also, and information that I don't have here in this line numbering is the schedule of the pipe, and that is very important because as the schedule increases, also increases the thicker of your pipe, and because of that the internal diameter of the pipe is smaller, and that means you have a higher pressure drop and a higher velocity also. And different than the nitrogen compressor P&ID, we have no information about the pressure rating of the piping, and so in this case I am not able to know if this stream is operating around 1 bar, 10 bar, 30 bar or 100 bar, because I have no information about the pressure rating. On the other hand, as I know in the nitrogen compressor system that I have a carbon steel 150, it means that I already have set a maximum allowable working pressure. For instance, in the nitrogen compressor discharge, I have the same CS 150B pipe material, so it means that we have already set the maximum allowable working pressure of the system, and we have a PSV that is a pressure safety valve. It is without a set because it's a preliminary drawing, but if I had a set of, for instance, 100 bar G, I know that something is wrong, because if I'm working with piping material rated for 150 pounds, it means that I can have something around 10 bar G as maximum allowable working pressure, depending on the operating temperature and pressure temperature also. It is very useful for safety issues, and as you have seen in the cooling system I don't have that kind of information. So there is no wrong or right in the project, so there is no wrong or right in plan design, but you need to be alert to that kind of information in your documentation in order that you can identify that, to know what is the pressure ratio of this piping. You need to go to the line list. If you don't know what is a line list, I will let you card here that you can see that with details or get familiar with that, because I have already recorded a video about that in my channel. Another example of line numbering is this one. So we have it 32. It is the pipe sizing, and it is in millimeter also, because we have a 1 inch manual valve here. And for instance, in this case we have a water liquid, and the pipe material is carbon steel, and the numbering sequence is 409. So my second tip to you understanding or start reading P&ID is taking a look in the line numbering, because it has a lot of information for you. And the third tip for start reading a P&ID is to get familiar with the legend and symbols for instrumentation. And in this case we have here a control valve and a dashed line connecting the control valve for a box with a square and a circle, and this box is connected to a circle also that is connected to a stream that in this case is our piping system. And with the table of legend and symbols, you will verify that the TT means temperature transmitter, because the first T is for temperature and the second T is for transmitter. And we have here a temperature indicator control, and this TAH and this TAHH and TAL means that we have sets for alarm and for shutdown. Usually when we have only one letter, it is for alarm, and when we have two letters of the same two letters, it is for shutdown. For instance, if we are operating in normal operations, we have 40 degrees Celsius for the temperature stream for this natural gas. If we reach 30 Celsius, the operator will receive alarm in the control room, telling him that something is wrong, but the system will keep running. And it is the same for TAH, and in this case, if we reach 50 degrees Celsius, it means that we have a disturbance in the process, but it keeps running. But for instance, if we reach 60 degrees Celsius, the TAHH will alarm and shut down the system. So that means that we usually will isolate the source of the disturbance and stop equipment to prevent safety issues. And TIC sends the signal to the control valve, and the control valve will modulate based on the signal. And you can see that in this P&ID, the representation of the control loop is very simple. We only have some boxes and indication of alarm shutdown, and it would be interesting to have an arrow in this dashed line, but if you get familiar with P&ID, you will know that the signal goes from the TIC to the control valve and not in the opposite. But in the other P&ID, we have a similar control for pressure, but it has much more information for us, because in this case we have P&ID based on the ISA, and in the ISA you will inform, or you will show boxes for switch temperature and to alarm also. So in this case we have the TI, the temperature indication, and if we will have also a set point for a TSH, that temperature switch high. So for some reason there is a higher temperature, the switch will do something, and if it gets too high, we'll have a switch that will result in an alarm and shutdown. It is a preliminary P&ID, so some information is missing here, because as we need to inform here the switch and the alarm. Without the alarm, in this case, the automation team will not program that. So even if we reach a higher temperature, abnormal temperature, but we don't have a TA, the operator will not receive an alarm in the control room. And we have here also, you can see that the information in the control valve is also different than the previous P&ID. Here we have the indication of the range of the signal that the control valve is controlled. So here we have 3 to 15 milliampere, and this recirculation valve, in the other hand, is 4 to 20 milliampere. And here we have also the indication of the instrument air and the filter regulator. So it means that the instrument air is is in a pressure higher than is allowable for the control valve actuator, and because of that we need a filter regulator. And here we have also the information of the fail-safe position of the valve. In this case we have fail close. So if the instrument air fails, or if the instrument air is closed, this valve will automatically or mechanically close, because it needs instrument air to operate. In this P&ID, we don't have this kind of information. At the first sight, we don't know if the valve safe position is closed or opened. Usually, for cooling system, it is fail open, because we don't want to take out the refrigeration in a cooling down process. But to confirm that, we need to go to the control valve process, to control valve data sheet, specification data sheet, and we don't have the information about the signal range. But as it is a control valve, and this is the representation of a diaphragm, it needs also instrument air, although it is not shown in the P&ID. And it is an interface between instrumentation team and piping team and the process engineering, and some companies prefer to have that kind of information in detailed design instead of showing that in the P&ID, because as you can see, there are much more information in the drawing when we use the ISA symbols and philosophy. And in this case, it's much simpler. There is no wrong or right, but you need to be alert to comply with the company requirements. And another thing that we would like to show you is that the control philosophy for the recirculation valve takes into account 3 signals. One for the compressor suction, that is the PT 251, goes to the PIC 251, and you can see here that we also have the alarm for high, alarm for low, and we have a PSL here. That means that some action should be done if the set point for this is reached, and it sends the signal for a PY that needs to choose from these 3 signals the higher one. This is the symbol for higher, so the signal that is higher is what will be selected to be sent to the recirculation valve. And one other interesting information here is that the reciprocate compressor, in this case we start that with the isolation valve closed and the recirculation valve opened, because it builds pressure too fast, and to prevent overpressurization we do that. And once we are closing the recirculation, the vent valve is opened to regulate the desired pressure. And in this case we could have also a sample tap for analyzer here to guarantee that the isolation valve would open only if the gas stream is at the right requirement for the customer. And don't worry about the control philosophy in this screen or in this drawing, because I will talk about that further in another video. And right now I would like to tell you that you just need to be aware of the symbols that you see in the drawing and the legend that is shown also, to understand what is the information that you have in your drawing. And you should be asking yourself, how can you identify that? What is each information, or what is the legend for each stream, and what is the symbols for each function. And that what is important to take a look in the standard, because most of the company's procedures are based on that. But for you that are following me up to here, I share with you some interesting information. First, I will share with you how it looks like a symbol chart. A P&ID drawing and a process flow diagram drawing are based on that. So it tells you what the kind of symbols and designation should be read in your P&ID. So in this case here, I have symbols for piping valves, and if I see in my P&ID a symbol like that, I know that it is a general valve. On the other hand, if I see something like that, it is a ball valve. And these drawings depends on your companies. Although they are similar, they can be different from one company to another. But once you need to read a P&ID, you should first go to the symbol chart to verify what is the meaning of each drawing in your document. So here we have the main line. See that the main line is thicker than the secondary line, and we have here the representation for the flags in left, out, right, and flags that is out, left, in right. In this case here we have liquid flow arrows and fittings and level sensors, general instrumentation function, and what kind of primary element flow rate. And for instance, this, if I see this in the P&ID, I know that is pitot tube type, and in the other hand, this is magnetic flow rate, and kind of primary element flow rate will depend on your fluid in your pipe. And we have almost all designation that you need to start reading your P&ID. And we have a second sheet here that talks about the letters, and that it is very important. For instance, the letters code for identification of instrument function. So we have seen in the case of TI that the first letter is T, so we have here temperature, and the second letter was I, so we have indicator. So TI is a temperature indicator, and we do the same for PIC and PI. For instance, PIC, first letter is P, so we have a key pressure, and the second letter is I, so we have indicator, and we have a succeeding letter that is C, that is control, so we have pressure, indicator, control. And it is how we start reading piping instrumentation diagram. And as I had promised for the in-process members, if you are not an in-process member yet, I will let available for them these two symbol charts in my Telegram in-process channel. So now that you are seeing this video, it is already available there in my Dropbox. So I share the link for my Dropbox, and you can get these two table sheets there. And with it, you will be able to faster your understanding in P&ID reading. I recommend you to get the symbol chart and analyze that, verify that, and watch the video again. Now with the printed chart, to help you in the understanding of this class. And finally, you may be interested in having these P&ID sheets for practicing P&ID reading. So I have two here, one for nitrogen compressor and the other one for DCA system. And in this case, I have a challenge for you, and if this video reaches 100 likes, I will let available in my in-process Telegram channel. I will let available these two sheets of P&ID there, so that you can get the symbol chart and the P&IDs and practice the P&ID reading. And I believe that will help you a lot in your chemical process engineer development skills. And so this is it, my friend. I hope you like it, and if you are interested in get this material, go to my in-process channel. You will have the link to join the in-process in this video description. And if you want to have the P&ID sheets for practicing, help me to share this video and this information, and once it reaches 100 likes, I will be very happy to share with you the P&IDs in my in-process free mentoring channel. Okay, my friend, my name is Jeferson Costa. I'm a chemical process engineer, and I'll see you soon in the next video.